Hi, I am Sue, and today my group and I will be presenting about the prediction of housing prices using AI. So my group members consist Paul, me, and Morgan. So for introduction, housing price prediction is critical for stakeholders. Example for investors, it helps to evaluate future returns on investment properties. Then for challenges with traditional methods, the limited ability to handle dynamic factors such as location, size, and market trends. And the objective of this project is to compare 5 AI models for housing price predictions. The 5 AI models are gradient boosting, random forest, SVM, nonlinear machine learning models, and linear regression. So for the AI models overview, gradient boosting captures nonlinear relationships, high accuracy, computational expensive. For random forest, it robust handles market fluctuations. And for SVM, it is reliable for small datasets, lacks scalability, and for non-linear machine learning models, it captures regional dynamics risk of overfitting. And last, for linear regression, it is simple, interpretable, and unsuitable for complex data. So for gradient boosting is a machine learning technique that helps us make prediction by combining the wisdom of many weak predictors to create a strong predictor. And for random forest, for example, suppose there's a dataset that contains multiple fruit images. So this dataset is given to that random forest classifier. The dataset is divided into subsets and given to each decision tree. During the training phase, each decision tree produces a prediction result, and when a new data point occurs, then based on the majority of result, the random forest classifier predicts the final decision. And for support vector machines, SVM operates by identifying the hyperplane that best separates data points belonging to different classes in a high-dimensional space. So as we can look at in this diagram, and by maximizing the margin, SVMs promote robust generalization and enhance the model's ability to classify unseen data accurately. So for non-linear machine learning models, we have linear regression. So as you can see in the diagram, linearly separable. So there's a line that separates it for as a region at x2 and x1. And here's another example. And for this is also another example, linear regression and non-linear regression. Now for the main AI model for this project, ordinary least square regression, OLS. So for OLS is a common technique for estimating coefficients of linear regression equations which describe the relationship between one or more independent quantitative variables and a dependent variable. Simple or multiple linear regression, often evaluated using R squared. Least squares stands for the minimum squares error, SSE, maximum likelihood, and generalized method of moments estimator are alternative approaches to OLS. In practice, we can use linear regression in many fields, such as economy. You can use to predict a company's turnover based on the amount of sales. Okay, so for next methodology, I'll pass it to Morgan. Thank you very much.
Thank you, so. I am Moganraj. Today I'd like to explain how the methods works for assignment on a housing prediction using AI. First, we did the data collection. The dataset includes from the source, which was created by individual Kagan on and pricing Kuala Lumpur, Malaysia. This dataset also includes the property features on location, size in square feet, number of rooms, and property age. And also, they listed on the market condition like rental demand or supply trends in Kuala Lumpur. This dataset includes on the housing prices like historical rental data covering various regions in Kuala Lumpur. The dataset captures enterprise trend across Kuala Lumpur, providing diverse features for analysis, including urban and suburban areas. This diversity enables the models to identify price patterns influenced by both property-specific and market-wide factors. For pre-processing, we did a data cleaning. The missing data was handled by filling missing values for size or local. The outliers, such as extremely high or low prices, were removed to avoid skewing prediction. Then, the property size and rental prices were scaled to ensure consistency and improve model accuracy. Example, analysis included upscale neighborhood like Mount Kiara with higher prices and outer areas with more affordable rentals, capturing a wide spectrum of the rental market. The above figure shows the prices difference between the Mount Kiara Astana and Arte Mount Kiara. Then we also did a selection for the AI model. First, we choose on OLS regression. We act as a baseline model to identify the relationship between variables. Example like size, rooms, and rental prices. Here we measure the proportion of variance in rental prices using the R square, which is explained by the model. And also, for coefficients, it quantifies the impact of independent variables on price. The p-values, which determines the statistical significance of variables. For example, for every additional room, rental price increased by RMX holding property size constant. Then we implement the random forest model selection. Purpose is for selected for its ability to handle diverse dataset and adapt to fluctuating market trends. It has strengths on reduced overfitting by averaging multiple decision trees and robust to outliers and noise in the data. For example, it accurately predicted prices for upscale neighborhoods like Mutiara and budget-friendly areas in suburban Kuala Lumpur. Then we choose gradient boosting for our AI model selection. It also used for high prediction accuracy by capturing intricate non-linear relationships in the data. The strengths are learns from errors iteratively, improving performance with each boosting step. And it also suitable for analyzing complex data sets with multiple interdependent features. Gradient boosting also has limitation on requires significant computational resources for training. Example, it effectively captures nuanced market dynamics such as price variation driven by the property age and location. Then with these types of AI model selection, we did a hybrid approach where we combine the strengths of random forest and gradient boosting to optimize the performance, where it likely ensures the stability in predictions across diverse and fluctuating markets, and also enhance accuracy by refining prediction iteratively. So the outcome will become balanced accuracy and computational efficiency, which delivers the robust and reliable predictions for our system. For performance evaluation, the metrics we use accuracy, which measure how closely the predicted values align with the actual housing prices and ensures that the model provides reliable and precise forecast for housing prices, and also helps in assessing the overall effectiveness of the model. Second is the precision, which evaluates the consistency and reliability of the model prediction across multiple datasets. And it also ensures that the predictions are consistently close to the actual values and minimizing deviations. A higher precision indicates the model's ability to perform well across various market scenarios. The third is for the computational efficiency, which assesses the resources and processing time required for the model to generate predictions and also helps in determining how well the model scales with the larger datasets or complex feature sets. This ensures that the predictions are made in timely manner without excessive resource consumption. Next is comparative analysis. This shows the difference on AI model selection, which will compare with our literature review. For the method of gradient boosting, it has strengths on handles non-linear relationship, but weakness in computational expensive. For random forest, it has strengths on robust, stable in fluctuating markets, but high resources consumption. The SVM effective for small dataset, but in poor scalability. The non-linear ML models capture regional market complexities, but weakness in risk of overfitting. The linear regression is simple and interpretable, but also limited to linear relationship. Then, next slide will be handle 2. How?
Next, we would like to propose our solution to the problem, introducing Smart House Price, the future of house pricing prediction. Our product is a dashboard that predicts housing prices using AI models. Users can enter property details and receive accurate price predictions along with valuable markets insight. You can see here that a user can type in the number of rooms and the size in square feet, and the model predicts the monthly rent in ringgit and also adapts to the numbers that are given for the number of rooms and size in square feet. Next, we would like to talk about the result and the discussion of the product. First, we start with a scatter plot analysis. The scatter plot analysis compares actual with the predicted prices, and for comparison, a 45-degree line, that means a line that assumes a linear relationship with gradient 1 between actual prices and predicted prices is plotted in this graph in red, and in blue is shown our actual values. You can see that the model demonstrates high accuracy with minimal prediction errors, and we do have a few outliers, but those were investigated and analyzed in the whole process. For our regression method, we used ordinary least squared. We could reach a high R squared, which indicates that the model fits the data well. We reached an R squared of 0.855. We then developed a graphical user interface using the Python library tkinter, where you can put in the number of rooms and the size in square feet, and the model predicts the monthly rent. Okay, now we come to the conclusion. AI-based prediction tools like our product, the Smart House Price Predictor, offer high accuracy and usability, and also they provide a great insight into market trends to get a good overview over the market. There are also a lot of improvements that can be done with our solution. For example, future enhancement could focus on the location or more inputs for the prediction, and there's also the opportunity to use more advanced AI models to improve the prediction even further. And I would like to thank you for your attention.